Hey everyone, it's your favorite new co-host Bilal Hankins here for a quick detour before we start the show. This spring we'll bring our 10th season of Elixir Wizards, and we are so thankful to you all for tuning in each and every week. We would love to make the show even better for you, so we created a short listener survey to get some feedback. If you could do us a quick favor and take 2 minutes to complete the survey, we promise to come back bigger and better in our 10th season. To take the survey, just click the link in our show notes for this episode or visit smr.tl/survey2022. Thank you for taking the time out of your busy schedules to help us understand how we can create an even better podcast for you. And now, on with the show.
Welcome to Elixir Wizards, a podcast brought to you by Smart Logic, a custom web and mobile development shop based in Baltimore. My name is Owen Bickford, and I'll be your host. I'm joined today by my co-host, Dan Ivovich. How are you, Dan?
I'm doing well, Owen.
Always. So this season's theme is Parsing the Particulars, and today we're joined by our recurring special guest, Chris Miller from Corvus Insurance. We're diving into the particulars of crafting a programming language. So how are you, Chris?
I'm doing well. Great to be here.
Awesome. Glad to have you back. I was just checking the podcast page. I saw that you were previously on the podcast May of 2021, so just over a year ago, year and a half almost. So curious, of course we can link back to that episode, but if you want to give us a kind of a refresher on who is Chris Miller, where you come from, where you're at.
Yeah, sure. I'm originally from Baltimore, so Baltimore is very close to my heart. I got my degree in mathematics, minor in Chinese. I'm really passionate about teaching math and computer science related topics. For a day job, I work at Corvus Insurance, which we use Elm and Elixir to build out the world-class insurance platform. I guess Chris Miller in a nutshell.
Right. Awesome. And so you mentioned Corvus. So is Corvus like selling its own insurance, or is it kind of a platform that sells multiple insurance options?
So we're at MGA, so we kind of sell insurance on behalf of multiple risk class partners, but we primarily work with cyber insurance and technology errors and omissions.
Awesome. It's that time of year, open enrollment. So
Yeah.
I'm sure insurance is on the top of just about everybody's mind if you're in a place to be insured. Awesome. So the topic today is crafting programming languages. I hear you have some thoughts. I guess to kind of get started, what excites you about the internals of a programming language?
So I think for me, it's not necessarily programming languages per se, but it's just more about languages in general. I study Chinese, German, Spanish, Hebrew, C, C++, Haskell, you name it, I've probably looked at it, APL. And it's really just the whole idea that when you learn a new language, you're learning a new way of thinking. And I'm just fascinated with new ways of looking at the world and new ways of thinking.
That's really neat. I guess I kind of wonder, with your background in math, doesn't that feel in conflict? Like, I don't think there's a whole lot of new math, right?
There's math coming out every day. There's tons of new math. I'd say that mathematics is actually a language in itself, and I call it the language of abstraction, the universal language. And learning new areas of mathematics really is just like learning new languages. Like when you look at linear algebra, you're talking about vector spaces and linear transformations, right? But then you can take those same type of concepts and apply them to other areas, like group theory. You're talking about groups and then group transformations, homomorphisms. So it's just like MathCon is very like synonymous with this whole language oriented idea.
Mm-hmm, mm-hmm. Yeah, I can really relate to that in some degrees. I remember distinctly the moment when I realized I could start learning computer languages and not foreign languages, and quickly put all of my energy into computer languages and not foreign languages. But then I also have a distinct memory in college toward, nearing the end, when I finally had seemed to have taken enough classes to make a lot of things that I'd struggled with prior click and just kind of all fall into place. And I think that kind of understanding of how things work, at least a little below the surface, is really helpful anytime you're learning something new to have that kind of deeper context.
Yeah, absolutely.
How far back do these interests go? Were you like studying Chinese in like grade school or like algebra stuff back then? Or like what's the progression here?
So I guess the language progression, I kind of started with Spanish and Hebrew and Greek. And that was back like in middle and high school. My dad taught me C++ when I was like 6 or 7, but I wasn't as like, gung-ho on programming at that time. I didn't really see it in that way. But my curiosity for, I guess, just exploring other cultures and other modes of thinking and ways of thinking has been there ever since I was very young.
Awesome. So I'm kind of curious, as we're thinking about programming languages, if let's say you're a coder, could be a new coder or someone who's maybe mid or even senior, and you're not writing a programming language yourself, what's interesting about how languages are crafted in the first place, either specifically with programming languages or spoken languages?
Yeah, so I think inherently language is about communicating ideas. And communicating ideas is like abstraction, essentially, right? When you think about what a programming language is it's a general abstraction over computation. And computation, like, built for some machine. Like, usually assembly or something of that nature. I'm not a hardware guy, so I'm not going to get into the details of that. But we're abstracting over binary bits when we're thinking about programming languages at a high level. And, for your everyday engineer, we use generic programming languages to build other things, right? Like web applications. That's what I'm familiar with. And essentially, we're building up web applications, and we could think in requests and responses, but what ends up happening is we want to abstract over that a little bit. We have the bits and the bytes of the web domain, right? So we end up actually building up this language that abstracts over like the plumbing for request and response handling. So I would say that everyone's building a language. It's just only certain people are actively talking about it.
Interesting.
That's a good refresher to, like the concept of domain-specific language. And I remember that was like a big thing in early Ruby days for me, and it doesn't come up a whole lot anymore. And I think in some regards, people have seen themselves paint themselves into corners by coming up with a language that then they have to maintain because, every abstraction comes with a maintenance cost. But yeah, the layered approach is really interesting and thinking about it from abstracting all the way down to assembly or to the actual binary commands, the instruction set codes that are running on a processor. And of course, this abstraction goes in the other direction too. We spend a lot of computer hardware is designed to deal with the weird abstractions we come up with in order to make processes go fast. We do all sorts of things for branch prediction and hyper-threading and all these things to deal with the fact that our abstractions are not perfect, and there's some clunkiness that goes with that. Of course, and compilers deal with that a lot too, unfurling loops and all sorts of things to make what our abstractions come up with go even faster. It's really interesting.
I'm curious, has anyone here ever written some raw assembly code?
I have.
I've done it like one time for a class, but not outside of that.
Yeah, in an academic setting, I've done it.
Okay. I've heard it described. I've not ever heard that and said, you know what? Today I write assembly code, so it just hasn't happened for me yet. Maybe never will.
Well, and I think to Chris's point about understanding the abstractions and what you're trying to communicate, there is value in, at least academically looking at what that looks like, how it has to work. It gives you an appreciation for the abstractions you have above it and helps you understand a little bit more as to, why things are the way they are, because, everything is built on the layer below and has to deal with some of those decisions.
Yeah, I think that's a really good point, especially nowadays. Working at a cyber insurance company, thinking about security all the time is always on my forefront. So when you layer all these abstractions on top of each other, sometimes there's a hole through those abstractions that becomes a security vulnerability.
Yeah, like if you decide to copy a string and not say how long you expect it to be, the classic example.
So speaking of DSLs or domain specific language, is that a part of the work you're doing at Corvus, kind of crafting a DSL for the specific problems you're working with in that domain?
Oh yeah, you can ask any one of my coworkers, like, what's Chris always talking about? We got to build some DSLs, man, for the insurance. Like, let's talk about what a quote request is, stuff like that. Language-oriented programming is something I'm very much so interested in. You think about sort of the different approaches you hear a lot about: top-down programming, bottom-up programming. Top-down programming is really difficult because you have to kind of have an expert there that knows the space fairly well and everything involved for you to come up with a system and go down. Bottom-up is difficult for a different reason. You're coming from a set of utilities and trying to just slowly build up a system over time. But then you have this other thing, which I recently found out was a mythology in this stack: middle out programming. You start in the middle. You capture like something about your domain space, and you build a DSL. You build your application on top of that DSL, and then you implement that DSL using your utility. It allows for ultimate flexibility in any software project you're building. It's like, oh, you need this new concept? Add it to your DSL. Really work on your DSL first before you build your application. Kind of goes back to the building library mythology that people kind of have, but it takes that a step further.
Now, in Elixir land, when I hear DSL, I think from talks that I've watched over the years, the first thing that comes to mind is macros, and Phoenix, that kind of thing. But I'm also kind of thinking of some recent project work I've done, building an application kind of in the middle of two different systems and trying to connect them together. So I'm kind of wondering if that is in the realm of the middle out approach. Does that sound right to you, Dan? Based on what you know about the client project?
Yeah, I mean, I think you could interpret it that way. And, the middle can be wherever you put it to some degree. I think there's the classic example of, what are all the nouns in my system? What are the events that go between them? Kind of your typical domain-driven type of assessments. I think one of the things that I caught on to with Phoenix and Ecto specifically was, the change sets and contexts. And it kind of does give you that boundary to say, these are the important nouns I care about, and I'm going to define an interface on how I want to interact with those. And then you do separate your presentation, whatever that may be, and it could be many different presentations, from the actual implementation, be that flat file storage, some sort of repository, something over an HTTP connection. And so you get that is a level of abstraction that we put even just within its own app. It doesn't have to be at an even larger scope, although it often is.
Yeah, so I think the example I'm thinking about is a behavior that I've defined for a particular type of work that needs to be done. So it lists, a bunch of callbacks. Some of them are optional, provides it does have like a using macro and that kind of thing. So is that kind of similar to how you're defining, if you're writing this in Elixir, is that kind of similar how you're defining DSLs at Corvus? Is there something more specific you're able to kind of dig into there, or without, spilling the beans?
Yeah, no, I think Dan's example of like Ecto, for instance, is like a perfect example of like sort of this middle out like programming, where you kind of start with your nouns and your relationships between those things and really focus on that without worrying about the underlying details. I don't necessarily, there's no beans to spill necessarily. I just don't want to spend here talking about insurance.
Sure. Oh, man.
Fair enough. Well, it does kind of make me think too, when you do learn other languages, whether that's a programming language or a spoken language, you often do start with like, what are the keywords? What are the nouns? What are the things I need to communicate about what's around me? Because like you said, Chris, like the whole point is an abstraction to convey meaning. to somebody, and often the what is this thing is the most important part of that communication, and the adjectives around it, those are often less important to convey the meaning behind something. It adds nuance and is important, but it can be a secondary step. And what it is and what you can do to it, what is acceptable, is probably the first thing that you really need to worry about in most cases.
Yeah, absolutely. It's I was just reading a paper from some company. I can't. I'll link it later here, but it was just talking about language-oriented programming or middle-out programming. This was first coined middle-out programming, but they have hence turned it into language-oriented programming. So you read a lot about this in the racket space, but using macros or DSLs to essentially build out your applications. And it's just a fascinating way of thinking about like software. And then when you relate that back to like actual natural language and going into like user research, like how do you build software? Software doesn't happen in a vacuum with the engineers. It's like you have to talk to the people that actually use it or need it, and you have to use their language. And oftentimes when you want to build new features, like you have to figure out, okay, what is that concept in my general programming language? So you're doing this translation, and it makes like coding anything very difficult, because it's like I need to constantly translate from what this person's domain is to like my code. And then if you leave, well, maybe your translation wasn't necessarily how the next engineer would translate it. So there's like this, I don't even know what you call that. This friction that happens. But if you
it's
just
definitely friction.
take the time to build a language, a shared meaning that is as close as possible to the domain, well, your next engineer doesn't really have to think about how to translate, because you've already done that.
Well, and I think that's an important point too. And it's a conversation I have with clients pretty often around, we want to change this label on this page. And it's like, okay, like, yes, changing that label is trivial, but it is in your benefit for us to change that everywhere, all down the stack, so that if we're going to change what that noun is, it's changed everywhere. Because otherwise, in 6 months, and that's optimistic, someone's going to come and look at it and be like, I don't understand why these are different. And, that, like you said, that meaning, that language, that reason, that translation will be gone potentially, or forgotten. And now you're in for a world of lack of understanding, which leads to errors and mistakes and regressions and a whole bunch of bad news.
All of this talk of nouns and domains, it's just reminding me of domain-driven design, and like how I've taken some kind of confusing projects where the requirements aren't really clear, and kind of started to ask questions like about the domain, and kind of applying those terms to the way that we name our modules and functions, so that it might even make sense, like the code might even make sense to a non-programmer, from that company. So yeah, that's a very, very useful way of kind of thinking through problems. And I think there's a lot of overlap between these concepts of domain-driven design and middle-out language-based design as well. Well, I'm curious, have you attempted to write your own programming language?
Yeah. So I had to do it as like an exam for a class, and that was like a kind of subset of OCaml like compiler. And then I started getting curious about what I could do like outside of the traditional means. I'm really passionate about teaching other people how to code. And I wanted to explore like how could I build an like educational language. This is still very much so like in the first couple of like commits or so. So this is like highly experimental. But essentially I wanted a language that would ask the user questions to get answers about the types and the relationships between those types, and it would write the program for the user. And then actually the user can go back through and look at what questions correlate to what code, essentially becoming like this teaching language based on inquiry. Because when I'm writing a piece of code, or when I'm thinking about like writing some software, it goes back to like, what the heck is this thing? Like, what is this language? And it's always a series of questions like, oh, what are your main things involved? How are they involved with each other? Like, are there numbers involved? What calculations are there? Like, and I'm still working on like this as I'm talking about it, but it's like building this inquiry tree, and then that inquiry tree can be transformed into a program tree with answers.
It's something that I'm kind of observing about you, Chris, is just like your passion for asking questions and kind of like figuring out what's going on. And I think, it's such an important skill in life, but particularly in this industry, is, that ability to ask good questions. And we say ask good questions. And I think sometimes we cause intimidation by saying that, because most questions are good questions. Probably all questions are good questions, especially when you're trying to decompose a problem that you must get to shared understanding on. And I think anything that we can do to encourage everyone we're working with to ask questions is important. And I really like your approach to making the questions be more about the abstraction than about the implementation or the technology or the language or the whatever. Is kind of really drawing that boundary and saying, let's talk about the domain. And I'm curious, when you are breaking down a domain with a team or whomever you're working with, do you have any like tips or pitfalls that you've seen when sometimes engineers will start to be like, oh, well, that sounds like this table or this database or this thing, which is really, I would argue, then starting to break your abstraction, because now you're talking about a specific thing and not the domain that you're trying to build around. Have you seen that? Do you have tips around kind of staying within a boundary?
Where other engineers go towards implementation, I go the other way, which is a separate problem. I go like, wait, what is this really? Like, I'm like, what concept is this? How can we abstract this? Like, I'm like, can we build the thing that builds the thing that builds the thing before I'm ever thinking about actually building the thing? And it's a problem. So when I'm talking to users, right, and we're talking about like something very specific, like I'm not trying to talk about insurance. Let's say
speak to what you know, Chris. It's all good.
Okay. I mean, no, I really don't want to talk about insurance. Let's say we're talking tic-tac-toe, right? So tic-tac-toe is simple.
Sure.
You're a user. You're trying to like place these objects on this grid, right? You want to play tic-tac-toe. It's very simple. Now, we could just say, all right, we spin up a grid that's a 3x3 thing and be done with it. But that's not the way I solve problems. That's not the way I tackle these things. I'm like, okay, well, how do you want to place things on this grid? Like, do we even need a grid? What's a grid? Like, I'm always asking like what things are. If I'm not sure of what someone is saying, I'm asking almost immediately, even if I already asked that question before, which is insane to some people. It's like, I have to be sure I know what it is what you're talking about. So I have to ask the follow-up questions. And I think that's like the biggest thing. It's like, if you have any inkling that you don't know what something is, you need to ask. If something else is brought up and you asking about that thing, you need to ask what that other thing is. You have to take your trails all the way down. And you have to do this within reason, which is why I'm saying I go way too far on this side of things, like, because you can't abstract everything. Or maybe you can.
Well, I think it's something I was thinking when you were saying that there too, is I think some of the really strong engineers that I've worked with, and Owen included, always take the time to restate their understanding of what they've been told in slightly different words, because that's a really good way to expose, something leaky in your abstraction. If you say, well, okay, what I heard is, or what I understand this to be is this thing in, as much different words as you can without, continuing to confuse the taxonomy, but, explain it again, in some different way to make sure that we all agree that either way, we're talking about the same thing. And I think it's related to what you're saying. I don't know that I've ever worked with anyone who had the problem where they go so far into the why, but I do like the philosophical part of what is a grid. I think that one might stick with me for a little bit after this call.
What is a grid, Dan?
It's a nested array.
Is it?
Maybe.
Could be a map.
It could be a function.
Could be a function.
It could be.
Yeah.
Yeah, to your point, Dan, like I think that's a skill I kind of picked up during my days in customer service of, I was doing technical support. So a lot of times I'd have someone, it's very different from like a client call, right? Like you'll get through this kind of like meandering kind of explanation of what's happening. It's kind of like a big word problem where some of this is relevant, some of it is not. And at the end of that kind of, sometimes it's venting, sometimes it's like just exasperation or whatever it is. Like you need to kind of restate what you're hearing in order to make sure that you're on the same page before you get started trying to actually solve the problem. Because a lot of times if you say, all right, I got this, without like checking yourself, you might wreck yourself. So you might go in, trying to solve the wrong thing and then wasting, if you're on a call with a customer, it could be half an hour or more, and that's bad. Or if you're an engineer, this could be very expensive because you might spend days or weeks working on the wrong problem. So that's just something I'll recap not only at the end of the call, but like throughout, and also keep asking why. The why is one that I try to ask more than I used to, because I find that very useful as well. Like, are we sure we really need to do this? Or why is this really a problem for you? Because that will uncover some additional problems that weren't quite part of the initial scope.
Yeah, like I guess another tip. Contextual inquiry is something that I do a lot. So I watch the users use the software and like I'll ask them, why'd you do that? And one thing I've noticed with other engineers is where they'll look at the behavior that is happening in the software, but not really question what the intended like effect is. Forget about what the software is doing. Forget about what I've built for you. What is it that you're actually trying to do? Like, if there wasn't a computer system that represented this model, how would you do it? Like pencil and paper. And you can catch a lot of like abstraction leaks that way. Just like, talk to me like I'm 5, walk me through the steps, and don't skip anything, and bring it all back to like pen and paper, whatever process it is you're trying to map. And doing it that way, you really do start figuring out why people are doing certain actions in your software, but also why people are doing certain things in general.
Mm-hmm. Yeah, I think we like to throw around the terms, business logic and, business value and, what's the use case. And it's a lot of ways of kind of skirting around what you're saying, which is, hey, can I just sit with you and understand what it is that you do so that I can build something that adds value to that, rather than implements the same process in a probably worse way that you're going to be frustrated about. It's an easy misstep to take when you're building software. And I think, our processes have to support figuring out kind of those details. I feel a little obligated to pull us back to Elixir, at least for a second here, and just say, you've experienced a lot of different languages from, spoken programming and abstraction. I'm just curious, what do you think in particular has influenced, or what about how you write Elixir maybe is like most influenced by your exposure to all these languages? Do you think you do Elixir in a different way because of all this experience?
I think the time I spent looking at how like Haskell and that community built out software has really kind of re-solidified those core functional principles that Elixir sits on top of. So when I'm writing Elixir code, I'm thinking about like, how can I write libraries to do the thing that I'm actually trying to do first? And yeah, that's taken me like miles, I would say. I also say the time I've touched Lisp and thinking about Lisp and macros and DSLs has allowed me to see Elixir as a Lisp. I remember when I was interviewing Jose on Code Next Door, a YouTube channel, and he was saying like, yeah, I got a lot of inspiration from Lisp. I did not see it at the time. I was like, I don't know what he's talking about. But now I do. It's just like, there's just like the heavy macro influence, the meta programming. It really just allows you to go. And the time I spent in the Python world, like I found Python, the tooling, like if I want to get a web app up fast, I can do that with Django and Flask. But like Elixir also kind of has that like Python feel to it. Like I can just spin up like a project super quick and like it doesn't make me think,
I think that says something to the value of these tools that kind of get out of your way, right? And I think, for a lot of people, or at least, for me, when I, first saw Ruby, it was like, okay, I understand these words. Like I understand how they get put together, and running a very basic Ruby script was trivial compared to, some other things that were, kind of harder to just get started on. And, I think Elixir has exposed the power of the Erlang VM to people who were just like, well, that's hard to get started on. So here's a kind of a gateway, an on-ramp to this world of now look at the power you have access to because we have made that initial abstraction more approachable.
Yeah, and I think tying this all of this back together, I think so in Elixir land, we're fortunate we've got maybe it's benevolent leader, but we have a very great community as well of people contributing to the language. And so I'm just kind of thinking, what if you were to take that college project and try to get to V1? Like, are there lessons you've learned from Elixir and from learning multiple different programming and spoken languages and asking questions and recapping problems? Like, how would you try to like get that project to like its version 1 if you wanted to like deploy like a new programming language?
Wow, that's a question. Let's see.
Too much question.
No, I think it's a good question, though. I would need to first define who it is I was building the language for. And I think, of all the things I've been thinking about learning, it's like starting with that. Like, the most important thing about the code is before you write any code at all, it's like, who are you building the code for? So it's like, I think about that audience. And it will probably be beginners to programming. And thinking about that audience, beginners to programming probably would like to see something visual, interactive, like immediately. And that kind of defines the scope of what types of like programs I want to transform into. So that tells me that maybe my target, when I'm building a language, I'm compiling to something. So I'm not going to compile to assembler or bytecode. I'm probably going to compile to like JavaScript. So I can use web apps, to quickly show people things. And I'm going to use web apps because everyone has a browser and can use that. So thinking about like who I'm building this for, it already tells me a lot about what I'm building. So now that I kind of know what I'm building, taking those principles of trying to break things down, I know I have something that needs to ask a series of questions. And I need those series of questions to be transformed into JavaScript somehow. And I can go further with this, but that's sort of like the outline there. I'm thinking maybe I need some idea of like what a node would be in this programming language. Most programming languages are based in tree structures. So I maybe need to think about like, how do you combine questions with their answers together to get to some type of like greater structure there. I need to figure out what my means of abstraction are in my question answer based language. I need to figure out what my means of application is in this question based language. And then I need to figure out how to translate that to JavaScript.
So let's say you've reached beta status or maybe V1 and you've got this kind of programming language that can ask a question and produce some JavaScript code, and the wild community comes forward and says, hey, we think you should add, I don't know, I'm trying to think of an absurd feature that I can say that won't like, start a flame war. Right. Maybe something outside of abstract thing that's outside of the scope of like what your language is trying to do, maybe CSS or something. Like, how do you respond to that? Is that something you kind of swat away, or like, how do you kind of address that kind of thing as you're crafting your programming language?
I guess I haven't really considered like how to deal with like what the community would want for said language versus what I would want for a language. I think that's a really hard question to think about. I think other language creators, like I'm thinking about Evan Zaplinski, the creator of Elm, he kind of has been touted as like this dictator that doesn't allow like these extra features that everybody needs or wants for the language. And he's like, well, those features would make the language more complex. And I'm trying to build something very simple for beginners. And there's this tension between like his vision and like people using it. And I don't necessarily know like how to navigate that space. I think I would go about it in the way where I would encourage maybe the open source approach. Be like, if you all want said, feature to this language, maybe I would chart out a path for it on how to add that. But like, I would be like, you can fork the project. But if it falls outside the concerns of sort of my focus and my user base of my ideal user, then I would probably have to maybe do something similar to what Evan does. That's a good question. I haven't thought about that at all.
I think we run into similar problems. Like, say you've defined a behavior and someone wants to do some like very specific thing. Like they want to add another callback that does like something a little bit more granular than what you think the behavior should actually do. Like, I think that's the point where you start asking questions, you asking the why, trying to recap the problem that's being expressed and say, all right, maybe this is already solved with the callbacks we have here. Or maybe we do add it, or maybe we just create like maybe it's a separate concern, like a separate behavior or something. I would imagine that would work similarly in the context of like a programming language or any application that you're kind of building.
Yeah, I guess now thinking about Elixir, Jose kind of handles most of these type of requests because he's given the language users the same capabilities as the language implementers with macros. So most things can just be like, well, yeah, sure, macro. Like I was at ElixirCon and we were talking about, hey, how can we add types into like Elixir? And I just remembered there's this Racket paper that it uses macros to add in a type system. It's called Turnstile. And I was like, wait, I can do that in Elixir. So I dumped the kernel out of Elixir and just started like building up my own version of def that was typed and took like colons for types and everything. And I abandoned said project when I found out that someone else built out a much further along version of it. I believe Quinn is their name. But that was really cool. It's just like, I don't need to ask Jose to add in types. I can add in types myself.
Right. I remember seeing some of that work on Twitter, and going to have to do some Googling on turnstile because types of turnstiles turns up different types of turnstile results in Google.
I believe the paper's called
naming things is hard.
Type systems as macros turnstile. Okay. And then they have a follow-up paper, type systems as macros using like dependent types using macros. So you can really do some wild things with just macros.
I think that's one of the great things here about, working on things that are being developed in the open, that you have access to all of it, is that you can push and you can see and you can poke. And, if you are the curious mind that, is working on these things, there's really no end to how deep, how far into the particulars you can go, which is one of the things that I think has been exciting about this season and these conversations, to really, kind of go below the surface of what it is we're working on. Something I did want to add to the conversation we were just talking about was this concept of, the kind of the expansion of an abstraction. And I think in a way it kind of relates to like the idea of, kind of taking on tech debt. And I was having a conversation the other day in that vein about how, anything you write, eventually you're going to get to a point where it's not enough and you have to modify it or expand it or change it in some way. And then an interesting kind of corollary to that is like, hey, can we just create some tech credit? Is there something that we can do to write it now, define the abstraction so well now that we can at least put off some of that a little bit further? And I think it's an interesting way to think about it. And it's an interesting challenge to have when you're doing your abstraction of like, how much can I future-proof this? But I also know that's like a dangerous slope to head down, because if you plan for the future too much, often your product doesn't get far enough to even get to experience it.
So very interesting thoughts along those lines. Sussman recently, he's like the author of SICP. He came out with another book and he's talking about like software design for flexibility. And he talks about like the idea of like building out DSLs actually allows for that like flexibility you're kind of describing. And there's this other like thing in compiler construction where people actually start off like, they're like, oh, we need to build up this giant compiler. Someone got an idea of, instead of building up this giant compiler that essentially does a bunch of different things, they can actually build out very, very small compilers that connect to each other. So you actually have languages that end up passing up through languages that do very small transformations. Now, Sussman in his like software design for flexibility, he kind of takes a similar approach. It's like, well, if you start with a DSL and then you realize you need to expand said DSL, just write another DSL.
And another kind of point that I was thinking about, just as all these kind of thoughts are kind of bubbling together, is I've learned some lessons from Elixir that when I work in other languages, I find it a little bit frustrating that they don't have the same kind of discipline, I think. So, Elixir being a functional programming language and like I would say a modern one, is only just crossed its 10-year anniversary. It tends to be more consistent than some we'll call older or legacy languages. So, and just the example that comes to mind is like order of arguments. So because Elixir allows you to pipe functions together, a lot of times within a module, you'll try to get, your kind of primary argument or your first argument should be consistent across that module's functions so that they can be piped together. Like the enum module is the greatest example of this. Like it always accepts some form of enumerable and then accepts maybe an extra argument or two and then some options at the end, or maybe a function at the end. So that type of like attention to like design and like ease of use for the end user. And when you think about like who's this language going to be for? Like, is this for like someone learning languages for the first time or someone who's working on a day-to-day basis? I think those kind of considerations can make a huge, huge impact.
Know your audience, ask a lot of questions, know your audience better, define your abstraction.
Exactly.
I love it. You just do those, everyone's going to be such a better programmer for having listened to this conversation.
And if you need to say no, either say it gently or say not right now. That's how you keep things from getting out of control sometimes. Like maybe later. Cool. So I think we've covered a lot of ground here. I think I found the link to the turnstile. I don't know if I call this a white paper, blog entry. I found a link to the turnstile stuff, so we'll have that in our show notes. And as we're wrapping up here, do you have any final plugs, side projects you want to get attention on, or hiring or anything else you want to mention here at the end?
I can't think of anything right now. I guess I started blogging at blackoiler.com. The site is still in the works, but that's about it. I guess I talk about some of these ideas there: middle-out programming, language-oriented programming, macros, DSLs.
All right, so we've got some reading homework. Elixir Wizards audience. All right, so we're going to hit up that website and be reading those articles. It's been so fun talking to you today about crafting programming languages, DSLs, abstractions, math even. So that's it for today's episode of the Elixir Wizards podcast. Thanks to our guest, Chris Miller, for joining us. I'm Owen Bickford, and my co-host is Dan Ivovich. Elixir Wizards is brought to you by SmartLogic with production support from Hanger Studios. Here at SmartLogic, we build custom web and mobile software. We work in Elixir, Rails, React, Flutter, and more. If you need a piece of custom software built, hit us up. Don't forget to like, subscribe, and leave a review. Those reviews help us reach new listeners. So you can find us on Twitter at SmartLogic or join the Elixir Wizards Discord. We'll have the link in the podcast page. We will see you next time for more on Parsing the Particulars.